Hello, and this is another phenomenal tutorial, and today we'll be focusing on a specific aspect of metadata management, and by creating prospectively an ISA archive using the Study Metadata Creation Galaxy Tool now available to you, and that is powered by the ISA API. So as you are familiar with the Galaxy environment, to find a tool, you just go into this menu here, create metadata creation, and select the ISAcreate Galaxy Tool, which will present you now with this new layout. So on top of the screen, you've got 4 sections, one that allows you to provide basic study metadata. Some of the fields are pre-filled. This is very basic information to allow you to describe the purpose and the scope of the study, and to provide information about the principal investigator, the person responsible that we should contact. Of interest to you here, there are these 2 fields which in the context of phenomenal are meant to make sure that you provide information about the terms of use of the dataset. And to do this, we have 2 dedicated fields which are powered by the data use ontology, which is recommended by the Global Alliance for Genomic Health, the GA4GH, and used by the European Genotyping Archive. These are drop-down lists where you can pick up the code that is most suited for your research and the terms of use, describe those. So this is a new feature in this release. So once you are done with providing basic information about the study itself, then we will go into the treatment plan, where the tool allows you to describe key information about the study design that will be used to power the creation and bootstrap the creation of the ISA document. Say the first kind of information that we require you is to tell us whether you are in a full factorial design or a fractional factorial design, and the user interface, as I will show you, will alter its behavior accordingly. So in the case of a full factorial study, the assumption is that you will be using all the groups, so it's a balanced design, and this is basically what the field allows you to do here, to specify the number of biological replicates for each of the group in the study. So we can say by default it's the triplicate, which is the most frequently used number of biological replicates. Then we have a field that allows you to specify the nature of the intervention that you are applying, the perturbation that you are applying to the system. In this example, we have a chemical intervention where we'll be testing 3 compounds at 3 dose levels, so intensity, marking the intensity of the stress, and 3 time points. So these are the 3 independent variables with the levels, and basically we are defining a 3 by 3 by 3 factorial design. So where you two have actually fractional setup, which means that you know that you won't be using all the possible factor level combinations, then this UI allows you to specify which group you will be using. It's more laborious, and you need to go over each of the group. However, you have full control about what is happening. So we can define as many groups as you want. Say here, again, taking the example of a exposure to a chemical compound, then we can specify the first time point, the second time point, time point 1, and the third time point. And of course, you would have to repeat that process. Now, you may have noticed that this button here, where we can specify whether the design is balanced or not. So if we set to no, which means that basically the group size will be of uneven sizes, then overall this situation is the same. However, we have a new field that allows you to specify the group size for each of the group. So classically in toxic exposure, high dose groups for ethical reasons tend to be reduced. So we could have, for instance, 10 animals in the low dose groups and only 5 in the second group. And of course, for each of the different study groups encompassing the range of perturbation that you may have defined in your study, you would have to do repeats. So moving on, once we have defined the treatment plan, then we can move on to declare the nature of the sample collection events that occur, and as well for each of those samples, which assay will be performed. So simply, again, proceeding in the Galaxy tool, we have to declare, the first step is to declare the kind of samples, and again, as you can see, this material type here is annotated with an ontology, which is UBERON, and we have pre-selected a number of organism parts that are relevant in clinical context, and all of them have been annotated with UBERON tags. And then the next step is to specify the number of sample collection events that will be taking place for this type of sample. So we could say we have, over the course of the study, 4 blood collections for the patients. And then the next bit is to specify that for each of these blood samples, what will be the type of data acquisition that will be performed, in other words, the assay plans. Here we have a number of drop-down lists. The first one is to select whether we want to work in mass spectrometry or NMR spectroscopy, and of course you can add as many assay plans as you want. So if we have NMR spectroscopy, mass spectrometry here, you can see that the UI is reactive to the selections, and then you can have you can proceed with supplying the relevant information. So let's assume that we have one acquisition using 1D NMR, and for that particular blood sample, and we would have for the mass spectrometry application, we would basically now have to specify which fraction we are investigating, the non-polar and the polar fraction, and then define the injection, the kind of sample introduction into the mass spectrometer that we have chosen. All these fields have been curated and informed by the terms used at EMBL-EBI Metabolights. So the tool, the ISAcreate Galaxy Tool, is completely aligned with curation practice at the European repository. So just to show you as well here rapidly that the dynamic aspects of the UI, so if I select gas chromatography, the fields are adjusted, and we have here the ability to provide information not only about the acquisition area, whether it will be in negative mode or positive mode, but also the nature of the derivatization that may be applied. Here again, this is control vocabulary coming from the Metabolic Standard Initiative ontology that is also available through the tool. So once we have done this process, we can move on to also report the kind of quality control and quality assurance plan that may be used in the study. And again, we have the ability to define a number of material type used as control and quality assurance purpose. And these terms are the result of the work carried out in the phenomenal to identify the different types of QCs. And so I will select the solvent blank, and I will also select another one, for instance, yes, a dilution series like this one. Okay, so once we have defined all these parameters, the last thing to do is to essentially execute and launch the job. So by clicking this button, the UI is updated and the job is sent to the queue. So it will take a bit of time for the process to be executed for the infrastructure to spawn all the workers. But usually the process is fairly fast, and we just have to be patient. In the meantime, I can point you to the organization of that particular, or the different tools that are available to bootstrap and speed up the creation of ISA archives if you're in the prospect of depositing data sets. So ISAcreate Metabolomic is a more top-down approach where you use information about the study design to guide the creation of ISATab archive, and this can be extremely useful when you are actually working on creating the pre-registering your study. The other aspect is that you can also work bottom-up, starting from a bag of MZML file or an MRML file to do that work. This will be the focus of another tutorial that we will be presenting. So let's go now to this data set. If we basically remind you to be logged in, to make sure that you're logged in, so you can enable the Scratchbook, and the file here will be presented, and this is triggering a visualization plugin that allows you to see, to mobilize, to render the ISATab archive, which is a tab delimited file, into a JavaScript plugin where you probably have a bit more information, even though, of course, this is a backbone, as I pointed out, but you can see the different factors that have been mentioned and the different assays. If you want to have a look at the samples, here is a rendering of the table. You can see how the information is regularized. You can see the ontology annotation showing up, but also the way the sample annotation has been structured. You have the QC injected here as planned for the, by the element. We can again reactivate the visualization component, and if you want to see a bit more about the assay table, again, you have this functionality available to you there. That's it. That was the first pass at how to create an ISATab document using the ISAcreate Metabol component. And in the next tutorial, I will show you how to execute an entire workflow that will allow you to create not only the ISA creator, the ISA tab document, but also to visualize them, to slice them, to see the kind of study groups, and eventually also to submit and deposit, pre-register your study to EMBL-EBI Metabolights. So thank you for the attention, and do not hesitate to contact us. You've got all the details to do so from the Phenomenal website. Bye.